Hello, my name is Aileen Zhu, and this is my arc length project. So the problem I'm trying to solve has to do something with my PE class from middle school. So in PE there will always be 2 yearly assessments based on your athletic performance, such as crunches, push-ups, running around an area, etc. And the one test that I remembered the most was running around the mile at Memorial Pool. So for this test, you have to run around Memorial Pool 4 times for a total estimated distance of around a mile. And this was timed. So I was wondering whether it was actually a mile if I were to run 4 times around Memorial Pool. Is it true that 4 times is enough, or is it too much and over a mile? So this is Memorial Pool. We would run around the track like this for 4 times, and it's thought that it was around 1 mile in distance. So I'll be trying to calculate the estimated distance for 1 lap to see if it is around 4 laps that around the pool will it equal to 1 mile. So I split into the pool into 2 parts. As you can see, the pool is kind of like a lopsided circle almost, and so I split it into an upper half and a lower half. You will get what I mean by this when I transfer this shape onto a graph. But first, let's get some important distances. To make measuring distances on Google Earth Maps easier, I decided to draw a sort of a polygon kind of shape. It's like a hexagon almost. Once again, sticking with the 2 parts, I bisected the shape in half, so it's about equal on both sides. By using the ruler function, I have found the sides of the length of each side of the polygon as shown. So now let's transfer this polygon onto a graph so we can calculate the arc length. So here is what the figure will look like once transferred onto a graph. On the curves, it will show both parabolas and the polygon associated with it. So it's equal on both sides, so it's kind of like a lopsided circle, but it's estimated like that. I then moved the polygon shape to make it more in line with the axis, with the bisecting line of the figure to be the x-axis, and to have the 2 vertices top and bottom of each, which are supposed to be the vertexes of each parabola, to be on the y-axis. This will make calculating the arc length a little bit easier. So in order to use the arc length formula to find the distances of these curves, we have to find and know the points on the graph. Here is a close-up section of the first top section. So we have the outside perimeter of the shape. The side here, which is 110, which is originally the full figure itself, is 220, is because it's bisected, so it will be 1/2 of that distance. And the same thing with the other side that was originally 350 feet has been 175. And as for the middle distance, which is the height of the figure, that was calculated by once again using Google Maps. As shown here, the height is calculated using the ruler tool function once again, measuring the 2 vertices to have the height. And the height is once again bisected. So with this information, we can easily find our first point, which is the maximum, which is 0.235. For the next distance, I'll be concentrating on the point over here. And this height is already given, as this is pretty much a straight line, so it's 110 in height. But we need to know the x value. So what is the x value? We can search that from Google Maps for measuring the distance across, which is the bisecting line itself of the figure. So that line across, once measured out, turned out to be 325 feet. So now that we know that this section is 325 feet in total, we can calculate the x value for this point. Now remember, we're assuming that this curve of the figure over here is to be a parabola, and a parabola is symmetrical on both sides. So it's safe to assume that both sides here are bisected evenly. Thus, for the x value here, it would be equal to 162.5 feet. With that given, the coordinates for this point becomes clear. It is negative 162.5, 110. And since we found out where this point is, we can also find a point that reflects right across the y-axis over here as well. So these 3 points will be essential to finding the arc length for this parabola. So now that we have the points, it's time to start graphing. So I decided to use Desmo's an online graphing calculator. I used the regression function on this. So I added all my xy values into a table and used the regression function. So I entered in the basic algebraic formula for a parabola and then let the computer do the rest of the work for me. So these variables will be replaced with this, which are the numbers for the formula. So it turns out for the formula of the parabola for our first upper curve turns out to be f of x equals to negative 0.004737 x squared plus 235. Now let's try to find the formula for the bottom part of the curve. So here's the bottom portion, once again all labeled with the parameters and their measurements. And of course we already know the height and it's bisected, so we know all of this. It kind of looks familiar, doesn't it? You'll see why later. Once again, we can easily find the minimum as we know the height of the figure, and the height is directly on the y-axis. So this is our first point, which is the same as the previous curve, 0, negative 235. It's just flipped over the x-axis instead. Now once again, I'm trying to find the second coordinate with the one with the 110 feet height, as this part is mainly straight, so it's safe to assume that this has a y value of 110, well negative 110 since it's in the third quadrant. And since we already know the across distance of this figure at the bisecting line is 162.5, so this coordinate will be negative 162.5, comma 110, the negative one. And as we know, parabolas are symmetrical on both sides, so if we reflect this point over the y-axis, which is like somewhere around over here, it will be 162.5, comma negative 110. Doesn't it sound familiar? It is the same as the curve that we did before. So this is great because that means they both have the same formula, just with different signs, as this will be positive as this is a positive parabola. And this is what the imagined parabola will look like. So we're going to calculate the length of the arc by using the arc length formula, which is L equals to the integral from A to B square root 1 plus parentheses f of 1 plus f1, the first derivative of x squared dx. Now we already know what our f of x is, which is just simply the formula. We're going to use the one with the blue figure, so the upper curve. And we just need to find the first derivative of it, which happens to be 0.009467x. So there we have our first derivative. Now we just need to find the a and b values. So the a and b values we're going to use will be when the curve, the parabola, intersects with the x-axis. So basically the x-intercepts. Once again, I used Desmo's online graphing calculator to find my x-intercepts. And these are the x-intercepts. So this will be my a and this will be my b. Okay, so now we have all the parts to our arc length formula. We have our a, which is negative 222.809, our b, which is positive 222.809, and our first derivative of f of x, so now we just need to plug and chug the formula in. So this is what the equation will look like once you plug in the values. I just realized that this part, I made a minor error from the beginning. This is actually for the red part of the curve, so it's for the red part, as the other one was negative. It was a careless mistake on my behalf, as the parabola was, after all, a negative parabola, so I lost the negative sign, but it's okay because they share the same x-intercepts, as they're the same formula, just different signs. So then after plugging this formula into our graphing calculator, the integral turns out to be, the answer is around 677.665 feet. This is for 1/2 of a lap. So to get the full lap, the full 1 lap, since both the equations have the same formula, just different signs, they're just flipped. That means we just need to multiply this by 2 times, and then we get around 1,355.33 feet for 1 lap. So now it's time to test our hypothesis that 4 laps will probably equal to 1 mile around the pool, more or less. So since we measured in feet, we will convert 1 mile into 5,280 feet, as that equals to a mile. So 1 lap equals approximately 1,355.33 feet. So if we multiply that by 4, that will give us a value of around 5,421.32 feet. Now those are pretty close values, but by running around the pool 4 times, it does go over a mile, just slightly. Around 2.68% if you were to count the percent error. So that was my arc length project, and we found out that running around 4 laps at Memorial Pool will give you approximately about a little over 1 mile in distance. And that is my project, and thank you for watching.